Alright guys, today we're going to work on our second topic for the Enlightenment. As you can see, the essential question we'll be talking about today is what ideas were promoted during the scientific revolution. As was explained in a previous video, the scientific revolution was a part of the Enlightenment, and in fact was a very significant part. To get us started though, we'll look at a little bit before the Enlightenment era. We'll look at science during the Middle Ages. Europeans saw a little difference between science and magic during the Middle Ages. They didn't really quite understand the world that was going on, so they assumed that it was just magic. Scientific explanations had two sources, and I'm sure you can imagine the church was the first one, and then ancient philosophers were the second. Aristotle used as the standard, so he was kind of put up on a pedestal, seen as the best philosopher that you could use to cite for evidence. Little known of the philosophers who disagree with Aristotle. So once again, Aristotle was seen as the best. If you disagree with him, then you were kind of forgotten about. In this case, we have Plato, Archimedes, and Ptolemy. All three of them very wise philosophers, but kind of forgotten about because they all disagree with Aristotle. Renaissance ideas will help change the science. Renaissance humanism changed study of science. People felt more free to question old ideas and beliefs. Remember, we talked about this during the Renaissance. The church did not have nearly the amount of power that they did before. Going along with that, trying to get to the past and idolize the past, people started to be able to read and write Greek and Latin. So they were actually able to read these old philosophers and their ancient writings. And people started to systematically experiment with natural phenomena. So they would start taking like, what is the rainbow? How does rain cause? How do rivers flow? They start looking at these questions and then start trying to answer them. Some causes and effects, as you can see, nothing too outrageous. Some causes: exploration and expansion of trade, continuing study of ancient authorities, and development of the scientific method, which hopefully you guys will have studied in one of your other science classes. Effects. Some of the effects of these causes: beginnings of modern sciences. So what we know of as modern science starts right here. Belief in progress and the power of reason. New view of the universe as a well-ordered system. So they started actually looking at the solar system and its place in the universe and figuring out how it all fits together. A couple real quick advanced in mathematics. You have the list up here of the three most important ones that came out in the Enlightenment. We have some people who we have the first one, create trigonometry. We have another one, invented a couple algorithms. Just quick notes. Going back to the geocentric model, which I hope you remember from the vocabulary video. Philosophers during the Middle Ages believed Earth is at the center of the universe. Remember, that's geocentric. That's the Earth is at the center and everything revolves around it. Also known as the Ptolemaic system. Universe is a series of concentric spheres, each one inside the other. Earth is motionless, so it's fixed in space. Everything else revolves around it. All other heavenly bodies, pure orbs of light, revolve around Earth, and God resides in the last sphere. So God kind of sits there and watches all the other spheres interact and what's going on. A couple of scientists during this Enlightenment period will try and kind of break out and actually explore this idea of Earth as the center of the universe. The biggest one would be Nicholas Copernicus. He offered a different view, the heliocentric, or the sun-centered model of the universe. Earth and planets revolve around the sun, and then the moon revolves around Earth. Earth rotates on an axis. I'm sure you guys remember this from your science classes in middle school and maybe earlier. Another one, Johann Kepler, used data collected by Brahe to form laws of planetary motion. And Kepler is the one who's actually going to take this idea of the sun is at the center of the universe, and he's going to run with it. He's going to go full blast with it. He's going to create the diagrams that we know of today as the model of the solar system. Orbits of planets are elliptical, sun at focus of each ellipse. Because as you can see from the diagram below, it's not a perfect circle. It's more of an ellipse, as he discovered. Another person is William Gilbert. Conducted extensive research on nature of magnetic and electrical attraction. So if you guys have ever tried to put a north and south pole magnets together and you feel the opposite, that power kind of trying to come apart, he's the one who does the research to discover that. Detailed observations in 1600 work, De Magnete, explained how a magnetic compass works. Earth acts like a giant magnet, has like magnetic poles, as you guys know, north and south poles, and he creates the word electricity. So pretty important guy right here. Galileo, I'm sure you've heard the name before. He made regular observations on the night sky using a telescope, and a pretty rudimentary one, but one that, nevertheless, one that made significant scientific advances. He's the first to see the mountains of the moon, 4 moons of Jupiter, and sunspots and Saturn rings. Publishes all his discoveries in 1 year, 1 book called The Starry Messenger in 1610. He is going to go against church teachings and warn not to defend Copernicus, because Galileo is going to take Copernicus's previous message about the sun being the center of the universe, and he's going to run with it. And the church is essentially going to put him on trial for it. They're going to say that he committed treason, essentially. He committed a crime against the church. And he's going to be found guilty of this, and he's going to be put under house arrest until his death in 1642. So he's put on trial in 1633, so for a good 9 years he's not able to leave his house or his property. You guys may have heard the story of Isaac Newton before. He's a mathematician and scientist who wrote Principia, one of the all-time most important books of science, Laws of Universal Gravitation. Each object in the universe attracts every other object. Doesn't matter how small it is, how big it is, it's going to attract every other object. Gravity depends on mass of each object and the distance between them. He used calculus to explain how gravity works, and he creates the 3 laws of motion, which you guys may have studied in a physics class or an upper level science class. Compared universe to a giant clock. Mathematics explained how parts work together. God created universe and then set the clock in motion, and he creates the basis for deism. So essentially he creates the basis for God starts the universe, but he doesn't interact with it. He just is the one that set it all in place. Just a couple quick notes on some biology and medicine. Andreas Vesalius dissected human and made repeated comparative studies. So he just kind of did what Da Vinci did. He got some bodies, dug them up, and then just kind of started studying them, cut them open, and saw what was in there. He describes individual organs, general structure of the body, and he refutes a previous idea of an ancient physician, Galen, and it pretty much gives us the basis for the modern human anatomy that we know of, and is one of the reasons why we know as much about the human body as we do. William Harvey explains how the circulatory system works. Once again, he gets in there, he gets a body, he gets in there, and just starts studying how the blood moves and the hearts and how it all connects. And he's the first to suggest humans and other mammals reproduce by fertilization of an egg by sperm. Then we also have the father of microbiology, improved design of microscope, and first to record observations of muscle fibers, bacteria, sperm, and blood flow in the capillaries. And then we also have the father of taxonomy, Corylus Linnaeus. He's the one who kind of, big botanist, famous botanist. He starts classifying plants by sexual parts. He creates the nomenclature, otherwise the vocabulary. He starts pretty much identifying, in grand total, he'll name about 7,700 species in all. Moving on to another area of science, chemistry, where you have Robert Boyle, first to define an element, matter of tiny cluster of particles. Boyle's law to describe the relationship between the temperature, pressure, and volume of gases. And then next up we have the father of modern chemistry, so if anybody's into chemistry, you guys have this one to thank. Created first periodic table of elements, invented the metric system, and he stated the law of conservation of mass. Not to forget about the women, we have Margaret Cavendish. She's not formally educated in sciences, but she writes about it. She's critical of the belief that humans were masters of nature. I actually thought it was the other way around, that nature were the masters of humans. Moving on, Maria Winkelmann. She's a German astronomer trained by her father and uncle, once again not formally educated. She discovers a comet in 1702 and also made observations about the Aurora Borealis. For those who don't know, Google Aurora Borealis. It is absolutely beautiful. She makes these observations in 1707. Moving on to Rene Descartes. He's a talented mathematician, but most famous for philosophical ideas. Scientists need to be able to reject old assumptions and teachings. You can use the old stuff for your basis of knowledge, but if you discover something new, you have to be able to forget about it and reject it. Knowledge relies on mathematics and logic, not experimentation. Everything should be doubted until proven by reason, the chief source of knowledge philosophy called rationalism. So pretty much don't believe something you read out of a textbook, only believe it if you actually can prove it through your own experience. His own existence was beyond doubt. One of the most famous quotes in all of history, I think, therefore I am. Rationalism is going to become very important to the scientific method. And once again, if any of you guys are into science, Rene Descartes is a huge father of it. Francis Bacon, just moving on very quick. Scientists should not rely on ideas of ancients. Hopefully you're seeing a common thread amongst these scientists that they do not want to rely on the past. They want to start building towards the future. Believe humans could control and dominate nature. Scientific method right here. Not going to really go over it. You guys, I'm sure, have seen it before. And that is it, guys. Next up, we're going to start talking about how these ideas actually build to what is called the Enlightenment, and take this idea of science and this scientific revolution and apply it to this new idea of not only just science and math, but government, philosophy, the arts, and everything else, and see how it impacts all the other stuff. Alright guys, I'll see you next time.